Yes, dear students. In last video, I was discussing measurement of temperature, but that remained incomplete there. To measurement of temperature, I told you that we choose some thermometric property which varies with temperature regularly, and if I let xt be the thermal property, temperature T and x100 and x0 at 0 degree centigrade, then T was there xt minus x0 upon x100 minus x0 into 100 degree centigrade. This was there, and I told you that this x may be volume of any material, liquid, especially in case of mercury thermometer. X means volume of the mercury liquid at different temperature. I told you it may be pressure of gas at constant volume. You will learn about gases in coming chapters. It may be resistance. I have told you, good conductor, and then I told it may be the thermo EMF. So X is the thermal property. On the basis of this, we have constructed different thermometer, like I told you, liquid glass thermometer like mercury thermometer, then constant volume gas thermometer, constant resistance of good conductor, and then thermo EMF. Generally we use liquid glass thermometer for simple measurement. If we use different liquids in thermometer, then those thermometers tell the different units of a given temperature except at x0 at x100. Value of xt will be different for a given hot body. It is a hot body, its temperature to measure, so we measure by xt x0 to fix है. But xt may be different for different liquid thermometers. So we need to prepare a thermometer which gives the almost same value of temperature. So that is called constant volume ideal gas thermometer. I say here ideal gas thermometer. Actually, in this thermometer, we measure pressure of gas at different temperature, keeping volume constant. And then, using this fact, Pt minus P0 upon P100 minus P 0 into 100, we can measure at low pressure. At low pressure, every gas behave in the same way. We know pressure of gas. Actually, there are gas laws. One is if volume of gas constant. Pressure and volume at a given temperature for a given mass, P is proportional to 1 upon V or PV equal to constant. This is called Bayes' law. From here you can write P1, V1 equal to P2, which is also good. For a given mass of gas, we have taken a given mass here In the gas keeping, if you keep temperature and mass of gas fixed here, if you change the pressure, then volume changes and PV remain constant. By also, then there is one law, Charles law. What is that? If we keep pressure constant, then if we keep volume constant, pressure, which is pressure constant, then rate temperature, then V upon T is equal to constant. And if we keep this also, if we keep volume constant, then P upon T constant. So every gas at very low density, or you can say at low pressure, behave the same way, and hence we use an ideal gas thermometer. Ideal gas thermometer. What is that ideal gas? No gas perfectly ideal, because only it behave like ideal gas at low pressure and high temperature. So what is there inside this? Actually here in the container, fixed volume, we fill a gas, and this container is connected to a manometer tube here. Here is the manometer tube. Now, to keep volume constant, here we fill mercury or alcohol. Generally we fill mercury. This tube is transparent. So now first of all we place this inside container at melting point of ice, measure P0. Then measure pressure at boiling point water, P0, P100. And then keep this. Actually from this value, we never need we always not need to measure P0 and P100. They are fixed for a given gas. Now we put the gas at T degree. Then we measure pressure difference here. Actually P equal to PA plus HDG, I told you while teaching manometer. So by measuring pressure we can measure the temperature of gas. But because here every gas you have learned, also all the relation PV upon T is equal to NR for a given number of mole. If we change pressure, volume, then volume, or we change temperature, pressure, volume change, but ratio remain constant. Or if we plot a graph here between temperature and pressure. For ideal gas, the graph come like this. It is at 0 degree centigrade, it is minus 273.15. If we produce it back, pressure appears to be 0. This is extrapolating or extending the graph backward, we get this temperature. But fact is that before reaching this temperature, every gas gets liquefied. Every gas gets liquefied, but it is imaginary, hypothetical. So this is called also absolute zero Kelvin. So minus 273.15 degree centigrade is called 0 Kelvin, and it is the base of Kelvin scale here. Here also real gases little deviate from this again. The graph may come like this, four different gases. PT graph. But this temperature is same for all. Suppose the gas, it is one gas, it is another gas, and it is this. A, B, C. If they are real gas, actually ideal gas concept is that in ideal gas there is no force of attraction or repulsion between the volume of gas or between molecule of gas. But actually there is a weak force for real gases. We have neglected while defining the concept of ideal gas. So this way we can, this temperature comes same, 273.15 Kelvin minus. Now in modern thermometry, we don't have two fixed points. Initially, while making or constructing a temperature scale, we choose two fixed points. One, the melting point of ice, which is given 0 degree centigrade in Kelvin scale and 32 degree Fahrenheit in Fahrenheit scale. But in modern thermometry, we have a single fixed point, that is triple pint of water. That is triple pint of water. Triple pint of water. Now you have heard this word first time. You might have heard about gas law in class 10 somewhere, but triple pint, TRIPLE. Triple point is a unique temperature, a unique point for every material. At this temperature, all the three state of matter of a material can exist together. Three state means solid, liquid, gas. A material can be obtained in form of solid, liquid and gas. Actually there is long discussion. For different materials this triple point different. For water ट्रिपल पॉइंट मैं यार क्या हो गया फोर वाटर ट्रिपल पॉइंट is 273.16 Kelvin and 0.006 atmospheric pressure. At this pressure and temperature, all the three states of water coexist It is different for different. I told you different for. So in modern thermometry, using relation. So according to modern thermometry. So according to modern thermometry, actually T is equal to Kelvin, sorry. T is equal to PT upon PTR into 273.16 Kelvin. This is the temperature. PT upon PTR into 2 PTR, you can write small also. It is PT upon TR. Pressure of gas at constant at triple point of water, pressure of gas at the temperature of body. So that way we need only one fixed point, because upper limit or lower limit REC, arbitrary. Things colder than ice are possible now. Then you have to tell the temperature minus. कहते ना भाई टेम्परेचर माइनस में है, तो एक्चुअली इन केल्विन स्केल माइनस टेम्परेचर डज नॉट मीन ओनली जीरो. दिस इज कॉल्ड एब्सोल्यूट जीरो टेम्परेचर. एब्सोल्यूट मीन्स no temperature lower than this are possible. Actual zero is 0 Kelvin. 0 degree centigrade. 0 degree centigrade is not actual zero. Zero means if your balance in your bank account is zero, means you have no money. Similarly, here temperature zero, then there should not be further any temperature. But things colder than ice are there. So in modern thermometry we measure. We take only one fixed point, that triple point of water, and using this fact we can tell the temperature. You may read constant volume gas thermometer. Actually, I have not given too much, because at this stage you don't know what are gas laws. After understanding gas laws, you will understand it better. So I gave you this idea of measurement of temperature in terms of different thermometer also, and I told you why we need a thermometer which give all the same temperature, है ना? Okay, and this is modern thermometry. Actually, I have to search for this. This is not written in every book. Even NCERT book has not written this thing. But this is important. And remember triple point. For water it is 273.16 Kelvin and 0.06 ATM. ATM is atmospheric pressure. For carbon dioxide, it is minus 78 it is 56 minus 56 degree centigrade and 5.11 ATM. So different material, but it is a unique temperature for every material. At a given temperature pressure, all three states can exist together. Now I will be coming in next video with thermal expansions.